Somewhere above you right now, if you could see through the ceiling and the atmosphere and the daylight or the dark, there are stars whose light is only now reaching your eyes. Light that left them long before you were born. From some of them long before anyone was born, long before this planet had cooled enough to hold an ocean. You're not seeing those stars as they are. You're seeing them as they were, and that old light is arriving in your present tonight, as fresh as anything you've ever seen. The past, in that gentle and literal sense, is still on its way to you. It has been travelling the whole time, and here is the second quiet thing, the one that begins to unsettle the first. When you look up and call this instant now, and someone drifting past you on a distant train, or on a spacecraft, or simply walking across the room, calls their own instant now, physics tells us there is no higher court that can say which of you is right, no single universal present that the whole cosmos agrees to share. Your now and their now can genuinely disagree about which faraway events are happening at this very moment, and neither of you is mistaken. The word now, which feels like the most solid word we own, turns out to have no single meaning that everyone in the universe can hold at once. So tonight I want to follow that thread slowly, all the way down, to a question that sounds almost childlike until you sit with it, and then it will not let you go. Does the past still exist? Not as memory, not as a photograph, not as light still crossing space, but as a place, as real as the room you are lying in. When a moment ends, does it truly vanish, swept away and gone? Or does it quietly remain, somewhere in the fabric of things, exactly where you left it, with you still inside it? There is a way of reading our best physics in which you have never once left any moment you have lived. We will come to that softly, and we will be honest about what is known and what is only beautifully argued. For now, just let the question rest there in the dark with you. Welcome. However you've arrived here tonight, I'm glad you came. Maybe you're listening from a quiet bedroom with the lamp turned low, or from a long train ride watching the dark country slide by, or from a couch under a blanket with the day finally behind you. Wherever you are, you can let your shoulders drop now. There is nothing to solve here, and nowhere to be. You do not have to follow every thread or hold every name. You're allowed to drift, to let the words become a kind of tide, and if you fall asleep somewhere in the middle, that is not a failure, that is the whole idea. We are going to take a long, slow walk through one of the oldest and strangest questions there is, and we're going to take it gently. If these quiet hours are something you would like more of, you might consider subscribing to the channel. It is a small and unhurried place, and every person who stays makes it a little easier to keep making these long nights of calm science for whoever needs them. No pressure at all. Only an open door should you wish to walk through it. Now, let us begin where everyone begins, with the feeling of time as you already know it, before any physics touches it. Think of a cup resting on the table in front of you. It is there now. A moment ago it was also there, and you have a memory of it being there, and you feel certain that in a moment it will still be there unless something moves it. This is the ordinary picture of time, and it is so deeply built into us that it feels less like a belief and more like simply seeing. There is the present, this thin, bright edge where things actually happen, where the cup is really sitting and the tea is really cooling. Behind it lies the past, which we imagine as a kind of vast darkened archive, everything that once happened but happens no longer, kept only in memory and in records and in the marks that events leave behind. Ahead lies the future, not yet real, a fog of things that have not occurred, waiting their turn to be born into the present and then to slip away behind us into the dark. And through all of this, we feel ourselves moving. The present seems to flow, to advance, to carry us forward like a small boat on a wide river. Moment after moment arrives, becomes vivid and real, and then is gone, and we are carried on to the next. This sense of flow is so strong that it shapes almost every word we have for time. We say time passes, time moves, time flies, time runs out. We speak of the river of time as if it were the plainest fact in the world. The present is where we live, the past is what we have lost, and the future is what we are rushing toward. That is the story we tell without ever deciding to tell it. Let that settle for a moment, because I want you to notice how completely natural it feels, and how little of it we have ever actually examined. We are so sure that only the present is real. We are so sure the past is gone. Ask yourself, quietly, why you believe that. not whether it is true, only why you believe it. And you will find, I think, that the honest answer is simply that it feels that way. The present feels lit up and alive in a way the past does not. The past feels like a story we can only look back on, never touch. But a feeling, however strong, is not yet a proof, and the history of physics is very largely the history of feelings, this strong turning out to describe something other than what is really there. Consider how it felt for almost all of human history, that the earth stood still beneath a moving sky. Nothing could be more obvious. The ground does not lurch, the walls do not sway, and the sun and stars visibly wheel overhead from one horizon to the other. Every sense you have agrees that you are still and the heavens turn, and yet you are, at this moment, being carried around the planet's axis at hundreds of meters every second, and around the sun far faster than that, and around the centre of the galaxy faster still, and you feel none of it, because smooth motion at a steady rate gives the body nothing to notice. The feeling of stillness was real. What the feeling reported about the world was wrong. So when I tell you that the flowing present also feels completely certain, I am not asking you to distrust your experience. Your experience is exactly what it is. I am only asking you to hold open the possibility that what it reports about the deep structure of time might, like the stillness of the earth, be a truth about how things seem from where we stand, rather than a truth about how things are. To go further, we'll need to be more careful about a few plain words, because the whole puzzle hides inside them. When you say two things happened at the same time, what do you actually mean? When you say the past is gone, gone from where, and gone for whom? When you say now, who's now, measured how, and agreed upon by which observers scattered across which distances? These sound like the fussy questions of someone determined to overcomplicate a simple thing. They are not. They are precisely the loose threads that, when pulled, unravel the whole comfortable picture and reveal a structure underneath that almost no one expects. Physicists did not go looking to overturn the river of time. They went looking, very practically, at light and clocks and the motion of moons, and the river of time quietly came apart in their hands. So hold on to your cup on the table, your simple, certain present, because we are going to keep it close as a companion and test it against everything we find. It will not survive the journey unchanged. But what replaces it, I think, is stranger and more beautiful than the story we started with, and, in its own quiet way, more comforting. Let us go and look. Let me stay a while longer with this ordinary feeling, because before we can watch it come apart, we ought to understand exactly what it is, and how much of our lives is quietly built on it. Consider the way you plan a day. You wake, and the morning is present, vivid, the only part of the day that is actually here. The afternoon lies ahead, unreal, a set of intentions and appointments that have not happened yet. The previous evening lies behind, real once but gone now, available only as memory. And you move through the day feeling yourself pass from one moment into the next, the present sliding steadily forward, the future becoming present, becoming past in an unbroken procession. Every plan you make, every promise you keep, every regret you carry, is shaped by this sense that time flows in one direction and that you are riding its current, unable to go back, unable to leap ahead, carried always and only forward at the same steady pace, and notice how deeply the language of it runs. We do not merely think this way, we speak this way, so thoroughly that it is almost impossible to talk about time without reaching for the metaphor of motion. Time passes, we say, as though it were a traveller going by. Time flies when we are happy and drags when we are bored, as though it had a speed that could change. We spend time, save time, waste time, run out of time, as though it were a substance we held in our hands and slowly let go of. We speak of the flow of time, the march of time, the river of time, and each of these images carries the same buried assumption, that time is a thing that moves, and that the present is a special place, the leading edge of that movement, the one real point where existence is actually occurring. There is a name for the two great families of belief that grow from this. The intuition that time genuinely flows, that there is a real, objective, moving present, is sometimes called the dynamic or tensed view of time, because it takes the tenses of our language, past and present and future, to correspond to real and different states of existence. Against it stands what is sometimes called the static or tenseless view, which holds that these tenses are not deep features of reality, but only reflections of where the speaker happens to be standing. The way the words here and there depend only on where you are and not on any real difference between places. We will not lean on these labels much, but it is worth knowing they exist, because they mark the oldest fault line in all our thinking about time, a fault line that runs from the ancient philosophers straight into the equations of modern physics, and along which, tonight, the ground is going to shift. Hold, too, onto how strong the tensed intuition feels, because its strength is exactly the thing we will have to weigh against the evidence. When you burn your hand, the pain is not a fact about a certain position in a four-dimensional block. It is happening now, unbearably present. When you dread something coming, the dread is precisely that it is not yet here but approaching. When you grieve because something is gone, has passed out of the world, exists no longer. All the weight of our emotional lives sits on the reality of the present and the unreality of past and future. This is why the question we're asking tonight is not a dry technical matter, but something that reaches all the way down into how it feels to be a living thing that remembers and hopes and mourns. If the past still exists, then grief is standing on ground that is not quite what it seemed. That is a large thing to say, and I do not say it lightly, and we will earn it slowly. Let us slow right down and build the idea of a present from the simplest possible scene, because everything that follows depends on getting this one thing clear, and the clearer it is, the more astonishing its collapse will feel. Return to the cup on the table. Right now, you would say, the cup exists, it is present. If I ask you what else exists right now, you might sweep your hand around the room, the lamp, the walls, the window, the dark garden beyond it, the street, the sleeping town, the far side of the earth, the moon overhead, the sun on the other side of the planet, the distant stars. All of these, you feel, exist right now, together, in one shared present moment, a single vast slice of everything that is, gathered under the one word now. This slice, this everything, happening at once, is the present as we naturally conceive it. It is not just the little patch around you. It is the whole universe caught in a single instant, every atom of it, frozen together in one shared now. And then that whole cosmic slice we imagine advances as one tick by tick into the next. Now here is the thing to hold, gently, before we ever touch relativity. That picture of one universe-wide slice of simultaneous events all advancing together requires that the words simultaneous have a clear, single, shared meaning across the whole of space. It requires that there be a definite fact about which distant events belong in the same slice as the cup on your table right now. The cup and the lamp close together easy, but the cup and an event on the moon, or the cup and an event on the far side of the sun, or the cup and an event in a distant galaxy, all supposedly gathered into the same universal instant. For the picture to hold, there has to be a real, definite answer to what is happening right now, at this instant of the cup, on that faraway world. The entire idea of a single flowing present stands or falls on there being such an answer, a fact of the matter about cosmic simultaneity. It feels so obvious that there must be one that we never think to question it, and that, precisely that, is the assumption that will not survive. When we say that relativity abolishes the universal present, this is the thing it abolishes, the shared meaning of now across distance, the definite fact about which faraway events belong in the same slice as your cup. Keep the cup close as we go. Its quiet presence on the table is about to teach us something the whole universe has been hiding in plain sight. Let us give the ordinary picture of time its proper name and its fair hearing, because it deserves both. Philosophers call it presentism, and the idea is simply this. Only the present moment exists. The past was real once, but is real no longer. The future is not yet real, and will only become real when it arrives. At any instant, the entire inventory of things that exist is exactly the things that exist now, and nothing else. The dinosaurs do not exist. Your grandchildren, if you have them or will, do not exist. There is only this thin, bright slice, this single shared present, and it is forever sliding forward, leaving non-existence behind it, and pulling non-existence in front of it into being. This is not a foolish view. It is, in fact, the view that almost every human being who has ever lived has held without examination, and it captures something we feel very deeply, which is that the present is special, that it is where the action is, that this moment has a vividness and a reality that yesterday simply does not. When you stub your toe, the pain is now. The memory of the pain an hour later does not hurt. There is an undeniable difference between living a moment and recalling it, and presentism takes that difference and builds an entire picture of reality on it. Only the lived edge is real. Everything else is either gone or not yet come. Picture time, on this view, as a river, and yourself as carried along on its surface. Behind you, the water has already passed and flowed away downstream out of existence. Ahead of you, the water has not yet reached you, is not yet real in your stretch of the river. You ride only the single moving line where you happen to be, the crest of the present, and that crest is the only place where anything is actually wet, actually real, actually happening. It is a lovely image, and it feels true, and for most purposes in an ordinary human life it works perfectly well. You need never question it to catch a train or bake bread or raise a child. The river of time is more than good enough for living, but notice gently what the river picture quietly assumes. It assumes that there is one river, one single current, one shared present line that everyone and everything rides together. It assumes that when it is now for you, it is the same now everywhere, that your present moment reaches out across all of space and picks out, for the whole universe at once, which events are happening right now and which are past and which are yet to come. It assumes, in other words, a universal present, a single, worldwide instant that sweeps forward together, the same for you and for me and for a creature on a planet circling a distant star. This assumption is so natural that stating it out loud sounds almost silly. Of course, now is now everywhere. What else could it be? And yet this is exactly the assumption that the physics of the last century took apart, quietly, carefully, and completely. It turns out that the universe provides no single river. It provides no shared present line reaching across space. The idea that your now and a distant now are the same now, that there is a fact of the matter about what is happening right now on a world many light years away, is not a harmless piece of common sense. It is a specific claim about the structure of space and time, and it is false, not unproven, not doubtful, measured, tested, and false. To see how we learned this, and why it forces the whole question of the past wide open, we have to go back before Einstein to a quieter discovery about something that seems to have nothing to do with time at all. We have to go back to the moons of Jupiter and to a patient astronomer who noticed that they were running late. Because the first crack in the universal present did not come from any grand theory of time. It came from someone realizing, to his own astonishment, that light does not arrive instantly, that it takes time to cross a distance, and once light has a speed, the simple word now begins, very softly, to come apart. It helps to see how old this quarrel is, because the intuition of the flowing present is not a modern conviction that a little physics can simply dislodge. It reaches back to the very beginnings of philosophy, and the fact that the sharpest minds of every age have wrestled with it and come away divided should make us gentle with ourselves for finding it hard. In the ancient world, the philosopher Heraclitus gave us the image that has echoed ever since, the idea that you cannot step into the same river twice, because the waters are always flowing on, and the river is never the same river from one moment to the next. For Heraclitus, change and flow were the deepest truth of reality, and the present moment, forever renewing itself, was where all of existence lived. Everything flows, he's remembered to have said, and nothing stays still. But almost in the same breath, the ancient world produced the exact opposite view, and produced it with arguments so sharp they have never been fully answered. Parmenides, and his student Zeno, argued that change and motion and the passage of time were, at the deepest level, illusions, that true reality was single and unchanging and eternal, and that the flowing world our senses report is a kind of surface appearance laid over a changeless depth. Zeno devised his famous paradoxes, the arrow that at every instant of its flight occupies a single fixed position, and so, he argued, is never actually moving, the runner who can never reach the finish, because he must first cross half the distance, and then half of what remains, and half again, forever. These paradoxes were not idle games. They were serious attempts to show that our common sense picture of motion and flow, when pressed hard, ties itself in knots, and that perhaps the changeless view was the truer one after all. So the fault line was there from the start, the flowing world of Heraclitus against the changeless being of Parmenides, and philosophy has swung between them ever since without ever quite settling the matter by pure thought alone. What is remarkable, and what makes our own moment in history so extraordinary, is that this ancient philosophical quarrel, which for more than 2,000 years lived entirely in the realm of argument, was suddenly, in the early 1900s, handed a completely unexpected new witness. Physics, pursuing light and clocks and the motion of the Earth, with no interest whatsoever in the old dispute between Heraclitus and Parmenides, stumbled into evidence that bore directly on it. And the evidence startlingly leaned toward the side almost no one expected, toward the changeless block of Parmenides rather than the flowing river of Heraclitus, though it did so in a way subtle enough that the argument continues even now. That is the strange gift of relativity to this oldest of questions. It took a matter that seemed forever beyond the reach of evidence and made it, at least in part, a matter of physics. In the 1600s, the great observatories of Europe were consumed by a very practical problem, one that had nothing to do with the nature of time and everything to do with the nature of money and ships. The problem was longitude, knowing how far east or west you were on the open ocean, and it was, at the time, essentially unsolved. A ship that did not know its longitude could miss an island by 100 miles, run aground on a coast it thought was far away, or wander for weeks looking for a port. Fortunes and lives depended on it, and one promising idea for solving it involved a clock in the sky, a natural clock that everyone on Earth could read at once, if only it could be understood well enough. That clock was Jupiter and its moons. Galileo had discovered the 4 great moons of Jupiter in 1610, and astronomers had come to realize that these moons, swinging around their giant planet in tidy regular orbits, disappearing into its shadow and emerging again with clockwork reliability, could serve as a kind of celestial timepiece. If you knew precisely when a given moon should slip into Jupiter's shadow, and you observed when it actually did from where you stood, you could compare your local time to a universal schedule and, in principle, work out your position. So astronomers set about doing the painstaking work of predicting these eclipses of the moons, building tables of exactly when each one should occur. At the Paris Observatory, a young Danish astronomer named Ole Roemer was doing precisely this careful work, watching the innermost large moon, the one we call Io, vanish into Jupiter's shadow and reappear again and again, night after night, season after season. And he noticed something that did not make sense. The eclipses were not keeping perfect time. When the Earth in its orbit was moving closer to Jupiter, the eclipses of Io ran a little early. When the Earth was moving away from Jupiter, they ran a little late. Over the months, as the distance between the two planets grew and shrank, the timing of these eclipses drifted, early then late, then early again, in a pattern that matched not the Moon's orbit, but the changing gap between the Earth and Jupiter. Roemer sat with this, and in 1676 he reached a conclusion that was for its time quietly revolutionary. The Moon was not actually early or late. The Moon was as regular as ever. What was changing was how long the light took to reach him. When the Earth was farther from Jupiter, the light announcing each eclipse had a greater distance to cross, and so it arrived later. Not because the eclipse happened later, but because the news of it had farther to travel. When the Earth was nearer, the light had less distance to cover and arrived sooner. The only way to make sense of the pattern was to accept something that many of the finest minds of the age had doubted. Light does not arrive instantly. It has a speed. It takes time to get from there to here. This was a profound break with intuition, and it is worth pausing on how strange it seemed. For most of history, thoughtful people had assumed that light was simply instantaneous, that when you opened your eyes, the whole visible world arrived in them all at once, present and simultaneous. Even Descartes, one of the sharpest thinkers of the century, had insisted light must be instantaneous and had staked strong claims on it. Roemer's moons said otherwise. From his figures, later refined by others using better values for the size of the Earth's orbit, the speed came out to something staggering and yet finite, a couple of 100,000 kilometers in every single second. Modern measurement has sharpened that number to very nearly 300,000 kilometers per second, a value we now know with extraordinary precision, but the essential discovery was already there in the tardy moons of Jupiter. Light is fast, almost beyond imagining, and yet it is not infinitely fast. It has a pace. Let that rest with you for a moment, because a great deal follows from it. If light has a speed, then every time you see anything at all, you're seeing it not as it is, but as it was when the light left it. For the cup on your table, the delay is so unimaginably tiny that it might as well be nothing, a few billionths of a second, utterly beyond notice. but the principle is exactly the same as for the star. Seeing is always seeing the past. There is no such thing as seeing something as it is right now, because now, for anything at any distance, is not a thing the light can deliver. The light can only ever bring you the past, freshly arrived. And here the quiet trouble begins. If light takes time to cross space, then the question of what is happening now on a distant world becomes genuinely awkward. Suppose you look at the sun. The light touching your eyes left it about 8 minutes ago, so you see the sun as it was 8 minutes in the past. What then is the sun doing now in your present, this very instant? You cannot see it. You can only infer it. And to infer it, you have to make an assumption about how to line up your clock here with events out there across a gulf that light itself takes time to cross. That lining up, that stretching of the word now across a distance, is not given to you for free by nature. It is something you have to define, and the moment you have to define it, rather than simply read it off the world, you have opened a door that Einstein would walk through and change the meaning of time forever. Because it would turn out that there is more than one way to line up the clocks, and no way to say which is truly right. I want to linger on Roemer's achievement a little longer, because the more closely you look at it, the more astonishing it becomes, and because it is a perfect example of the kind of quiet, patient, indirect knowing that this channel loves. Roemer never measured the speed of light directly. He had no way to do that. No apparatus that could clock a beam of light across a laboratory. Nothing remotely fast enough to catch it. What he had instead was the solar system itself, turned into an instrument, and a moon that served as a hand on a vast clock, and a willingness to trust a small stubborn discrepancy in his numbers rather than explain it away. The eclipses of Io ran early by a matter of minutes when the Earth was near Jupiter, and late by minutes when it was far, and the total swing across the year amounted to something like a quarter of an hour, roughly, this being the time light needed to cross the changing distance across the Earth's own orbit. From that swing, and an estimate of how wide the Earth's orbit was, a speed could be extracted. The number that came out was not quite right by modern standards, because the size of the Earth's orbit was not yet well known, but it was right in the way that matters most. It was the correct order of magnitude, it was finite, and it was staggeringly large. Later in that same era, the astronomer Christian Huygens took Roemer's timing and combined it with a better figure for the distance, and arrived at a speed in the neighbourhood of 200,000 kilometers per second, in the right country, so to speak, if not yet at the right address. Over the following centuries, as methods sharpened, first other astronomical measurements, then ingenious experiments with spinning-toothed wheels and rotating mirrors carried out on the Earth itself by people like Fizeau and Foucault in the 1800s, the figure was refined and refined again, closing in on the value we hold today, close to 300,000 kilometers in every second. A value now fixed so precisely that we use it to define the very length of the meter. But it began with a Danish astronomer and the moons of Jupiter, and the courage to believe a small anomaly. And I want you to hold, as you drift, the sheer scale of what that number means, because a figure like 300,000 kilometers per second is so far outside human experience that it can wash over you as merely a large number, and it deserves better. In a single second, a flash of light could circle the entire Earth not once, but nearly 8 times. Light from the moon reaches your eye in a little over a second, so the moon you see is always the moon of a second and a bit ago. Light from the sun, as we said, takes about 8 minutes, so the sunrise you watch already happened, out there, 8 minutes before you see it. Light from the next nearest star beyond the sun takes more than 4 years, so its light to night left it during a season you can probably remember. And light from the faint smudges of distant galaxies has been travelling for millions and even billions of years, so that to look deep into the night sky is quite literally to look deep into the past, to see things not as they are but as they were before the Earth existed. The finite speed of light turns the whole sky into a kind of archive, every point in it showing you a different depth of the past, all of that old light arriving now together in your single present glance. The night sky is not a picture of the universe as it is. It is a picture of the universe's history, all its ages layered into one view. Let that settle, and feel how the simple discovery of Roemer opens quietly onto something vast. There is a human detail in Roemer's story that I cannot resist giving you, because it shows how hard it is, even for brilliant people, to let go of the feeling that light is instant. When Roemer presented his conclusion, that the delay in the eclipses meant light travelled at a finite speed, not everyone was persuaded, and among the doubters, for a time, was the director of the very observatory where Roemer worked, the great Italian astronomer Giovanni Cassini, one of the finest observational astronomers of the age, the man whose name we still give to the beautiful gap in the rings of Saturn. Cassini had himself noticed the timing discrepancies in the moons of Jupiter, had even entertained the idea that light might take time to travel, and then had drawn back from it, preferring to think that some other complication in the moon's motion was responsible. It was Roemer, younger and bolder, who took the discrepancy at face value and followed it to its startling conclusion. And history, in this case, sided with the bold young man rather than the cautious master, though it took decades and further evidence before the finite speed of light was fully accepted. I tell you this not to diminish Cassini, who was magnificent, but because there is something reassuring in it. Even the greatest observers hesitated at the edge of this idea. If the finite speed of a light, which we now teach to children, was hard for a master astronomer to swallow, then you may forgive yourself entirely for finding the stranger consequences we are building toward difficult to hold. The difficulty is not a failure of yours. It is built into how far these truths lie from the world our senses were shaped for. Come forward now to the year 1905, to a patent office in Bern, Switzerland, where a young clerk named Albert Einstein spent his days reviewing applications for electrical devices, and his evenings turning over a problem that had been quietly troubling physics for decades. The problem, in its simplest form, was about light and motion, and about a stubborn number that refused to behave the way everything else in the world behaved. Experiments had shown, to the puzzlement of nearly everyone, that the speed of light seemed to come out the same no matter how you were moving when you measured it. This should have been impossible. If you run toward an approaching wave, it meets you faster, and if you flee from it, it catches you slower. That is how speeds add up for every ordinary thing, for balls and boats and sound. But light did not obey. Chase it or flee from it, the light came out at the same steady pace every time. Einstein made a daring choice. Instead of treating this as a paradox to be explained away, he took it as a starting truth to be trusted, and he asked what the world must be like if it were simply, fundamentally so. What if the speed of light really is the same for every observer, no matter their motion? He followed that single assumption with relentless honesty, and it led him somewhere that overturned 2 centuries of settled physics, and, with them, the universal present. Because if the speed of light is fixed for everyone, then something else has to give, and the thing that gives, astonishingly, is the agreement about what happens at the same time. Let me show you this the way Einstein liked to show it, with a simple scene you can picture as you lie there. Imagine a long train moving smoothly down a straight track, and imagine that lightning strikes the 2 ends of the train, the very front and the very rear, and leaves scorch marks both on the train and on the track beneath. Now, standing exactly halfway along the platform is an observer on the ground, and sitting exactly in the middle of the train is a passenger moving along with it. The question is deceptively simple. Did the 2 lightning bolts strike at the same time? For the observer standing on the platform, let us say the light from both strikes reaches her at the very same instant. The 2 flashes arrive together, and since she stands exactly midway between the 2 scorch marks on the track and light travels at a fixed speed, she concludes, quite correctly for her, that the 2 strikes were simultaneous. They happened at the same time, front and rear, together. But now consider the passenger seated in the middle of the moving train. During the tiny interval while the light is travelling inward from both ends toward him, the train carries him forward, toward the front strike and away from the rear strike. So the light from the front, which he is moving to meet, reaches him a little sooner, and the light from the rear, which is now chasing him as he pulls away, reaches him a little later. He sees the front flash before the rear flash. And because the speed of light is the same for him as for anyone, he cannot explain this away by saying the light went faster or slower. He must conclude, quite correctly for him, that the front of the train was struck first, and the rear struck afterward. For him, the 2 events were not simultaneous at all. They happened in sequence. Sit with this a moment, because it is one of the most important facts in all of physics, and it slides past so quietly. The 2 observers are not making a mistake. Neither one has misread an instrument or miscounted. There is simply no fact of the matter, no privileged truth, about whether the 2 lightning strikes happened at the same time. For the woman on the platform, they were simultaneous. For the man on the train, they were not. Both are right. Simultaneity, the very idea of two distant things happening at the same moment, is not a feature of the universe that everyone shares. It depends on how you are moving. Physicists call this the relativity of simultaneity, and it is not a philosophical flourish or a trick of perception. It is a measured, tested, foundational feature of reality, as solid as anything in science. Now feel what this does to the river of time. The river picture, remember, needed a single shared present, one now sweeping across all of space, the same for everyone. But if two observers moving differently cannot even agree on whether two events happened at the same time, then they cannot agree on what belongs to now. Your present moment, the set of all events you would call happening right now, and the present moment of someone moving past you, their set of events happening right now, are genuinely different sets. Your now and their now slice through reality at different angles. There is no universal present line. There is no single river. Each observer has their own present, tilted slightly from everyone else's, and the faster the relative motion and the greater the distance, the more sharply those presents diverge. For someone in the room with you, moving slowly and standing close, the difference is unmeasurably small, which is why we never notice it and why the river of time works so well for daily life. But stretch the distance out to a faraway galaxy, and even a gentle stroll across the room can shift your present on that distant world by years. Walk one way, and events there that you count as happening now lie in what someone else would call the future. Walk the other way, and your now out there slides into what another would call the past. The same distant moment can belong to one person's present, another person's past, and a third person's future, all at once, with no one wrong. The word now has quietly shattered into countless different nows, each as valid as any other, and there is no master now standing above them to say which is the true one. And so the loop the night opened begins to tighten. If there is no single present that everyone shares, if now is relative and sliced at different angles by different observers, then what becomes of the claim that only the present is real? Whose present? Yours, or the one moving past you, whose now includes events you would swear are still in the future or already lost to the past? The moment we take relativity seriously, the tidy division of time into a real present, a vanished past, and an unborn future stops making sense as a description of the universe as a whole. Something else is needed to hold all these tilted presents together in one consistent world. And in 1908, a mathematician who had once been Einstein's teacher found exactly what that something was. Let me stay inside Einstein's reasoning a little longer, because the step he took is so easily stated and so rarely felt in its full audacity. Before him, everyone assumed that time was a universal backdrop, the same everywhere, ticking along identically for all observers, a great cosmic clock that stood outside events and measured them all impartially. Isaac Newton had written this assumption into the foundations of physics 2 centuries earlier, speaking of absolute time that flows equably without regard to anything external, and for 200 years it had seemed simply obviously true. The stage on which all of physics was performed. Space was the fixed stage, time the fixed clock, and events happened within them. What Einstein saw, following the fixed speed of a light with pitiless consistency, was that this could not be. If light always comes out at the same speed no matter how you move, then two observers moving differently, measuring the same beam, must be measuring space and time themselves differently, because speed is just distance divided by time, and if the speed is pinned to be the same for both, while their motions differ, then their distances and their times must flex to compensate. Time could not be the fixed universal clock. It had to be something that each observer carried with them, running at a rate that depended on their motion. This is why the relativity of simultaneity is not a small technical footnote, but the hinge of the whole thing. Once time is no longer universal, the idea of a single now spanning all of space loses its foundation. Think again of the woman on the platform and the man on the train, but now feel why neither can be corrected. You might want to say, surely one of them is really right. Surely there is a true fact about whether the strikes were simultaneous, and one of them simply has a distorted view of it. But that is exactly what relativity forbids. The principle at the very heart of the theory is that there is no privileged observer. no one whose state of motion is the true rest against which all others are moving. The woman on the platform feels at rest and sees the train move, but the man on the train with equal right feels himself at rest and sees the platform and the whole earth slide past beneath him. Neither is really moving in any absolute sense, because there is no absolute rest to be measured against. And if neither is privileged, then neither one's judgment of simultaneity is privileged either. Both are simply true, each within its own frame, and there is no higher frame that overrules them. I find it steadying somehow to remember that Einstein reached all of this not with a telescope, or a laboratory full of equipment, but largely by thinking, by taking a strange experimental fact seriously and refusing to flinch from where it led. He was 26 years old, working 6 days a week assessing patents, doing physics in the evenings and the stolen hours, and in that single year, 1905, he produced not only this reworking of space and time, but several other papers that would each, on its own, have secured his place in history. It is sometimes called his miraculous year. And the piece of it we are following tonight, the relativity of simultaneity, is in some ways the most quietly revolutionary of all, because it did not merely add a new law to physics. It reached into a concept everyone thought they understood completely, the concept of two things happening at the same time, and showed that it had no absolute meaning at all. It is rare for science to do that, to take a word so basic that we use it without thinking, and reveal that beneath it there was never solid ground, only the appearance of it, good enough for slow lives lived close together and quietly false about the universe at large. Let me put some numbers to the smallness of these effects at everyday speeds, because it explains a puzzle you might be feeling, which is why, if simultaneity really is relative, we never once notice it in ordinary life. The reason is that the mixing of space and time only becomes appreciable when speeds climb toward the speed of light, and everyday speeds are so far below it that the effects shrink almost to nothing. Consider that the speed of a light is around 300,000 kilometers in a single second. Now consider a fast passenger jet moving at perhaps 1/4 of a kilometer per second, a good clip for a human being. Compare those, and the jet is travelling at roughly 1/1,000,000th of the speed of light. The relativity of simultaneity, the tilting of the slices, depends on this ratio, and at 1/1,000,000th, the tilt is so tiny that for two events even thousands of kilometers apart, the disagreement about their timing amounts to unimaginably small fractions of a second, far below anything a person could ever sense. This is why the river of time works so flawlessly for us. We crawl through the world at a snail's fraction of light speed, our slices barely tilted from one another, and so we all agree, to the limit of any perception, on one shared now. The universal present is not exactly true, but it is so nearly true at human speeds and human distances that the error never surfaces in a life. But the error, though tiny, is not zero, and this matters enormously, because it means the universal present is not merely hard to measure, it is genuinely absent. A thing that is very nearly true and a thing that is exactly true are different in kind, not just in degree, and the whole weight of our question rests on that difference. If the universal present were exactly true and merely hard to detect, the block universe would have no foothold. It is because the universal present is actually precisely false, false by a tiny amount that grows without limit as distances and speeds grow, that the door to eternalism swings open at all. The smallness is why we never noticed. The falseness is why it changes everything. Both are true at once, and holding both is the key to feeling why a truth this strange could have hidden from us for the whole of human history until a patent clerk in Bern followed a beam of light with unusual stubbornness and found the present quietly coming apart in his hands. His name was Hermann Minkowski, and he had taught the young Einstein mathematics in Zurich, where he had, by his own later admission, thought of his student as something of a lazy dog, clever but disinclined to work. When Einstein's theory of relativity appeared and shook the foundations of physics, Minkowski saw something in it that even Einstein had not yet fully drawn out. He saw that the strange behaviour of time and space, the way they seemed to trade off against each other, the way simultaneity dissolved and clocks disagreed, all of it fell into a beautiful and simple order if you stopped thinking of space and time as two separate things and started thinking of them as one. In 1908, Minkowski gave a lecture that opened with words that still send a small shiver through anyone who loves this subject. He said that from that hour on, space by itself and time by itself were destined to fade away into mere shadows, and only a kind of union of the two would preserve an independent reality. What he meant was this: we're used to thinking of space as a three-dimensional stage, with height and width and depth, through which time flows as a separate thing, an outside clock ticking along independently. Minkowski said, no. Time is not separate from space. Time is a fourth dimension, woven together with the three of space into a single unified fabric, one four-dimensional whole. He called it spacetime, and the word has never left us. This is a genuinely difficult thing to picture, and I do not want to pretend it is easy, so let us build it slowly. Think first of a single point in space, a place, which you can specify with three numbers: how far east, how far north, how far up. That is ordinary space, 3 dimensions. Now Minkowski says, to fully locate an event, a happening, you need a fourth number 2 when it occurred. Not just where the lightning struck, but where and when. An event is a point not in space, but in space-time, fixed by 4 numbers together, 3 of place and 1 of time, and the full arena of everything that ever happens or ever will is this 4-dimensional expanse, this vast fabric in which every event, past, present, and future, sits at its own fixed location. Imagine, if it helps, weaving on a loom, threads running one way for space and another way for time, crossing and binding into a single cloth. In that cloth, your whole life is not a moving point but a long thread, a continuous line running through the fabric from the event of your birth to the event of your death, passing through every moment in between. Physicists call this thread your world line. Every object has one. The cup on your table traces a world line, mostly still in space but always advancing through time. The Earth traces a great helical world line as it circles the Sun. A beam of light traces a world line too. Everything that exists is, in this picture, not a thing that moves through time, but a shape laid out in space-time, complete from one end to the other. And here is the quiet power of Minkowski's vision, the reason it swept through physics and never left. All the confusing, slippery effects of relativity, the disagreements about simultaneity, the stretching of time, the way different observers carve up now differently, all of it becomes clear and simple once you see it as geometry in this 4-dimensional fabric. The 2 observers who disagreed about the lightning strikes are simply slicing the same unchanging space-time at 2 different angles, like 2 bakers cutting the same loaf of bread with their knives held differently. The loaf is one definite object, but one baker's slice and another baker's slice, tilted relative to the first, pass through different crumbs. Each slice is that baker's now, their present moment, their sheet of simultaneous events. And because the slices are tilted, they disagree about what lies in the same slice, what counts as happening at once. The disagreement is not about the loaf, which is fixed and whole. It is only about how you cut it. This is such a fertile image that we will keep returning to it, so let it settle in fully. The loaf is all of space-time, every event that ever happens, sitting there as one 4-dimensional whole. Your present moment, right now, this instant you feel yourself living in, is one slice through that loaf, one flat sheet gathering all the events you would call simultaneous. Someone moving relative to you slices the loaf at a slightly different angle, and their present sheet gathers a slightly different set of events. Neither slice is the true one. The loaf does not have a correct way to be cut. It simply is entire, and the slicing is something observers do to it, each in their own way. Do you feel where this is heading? In the river picture, the present was the only real thing, and it moved. In Minkowski's picture, the present is just a slice, an angle of cut, and the whole loaf, past and future together, is equally there to be sliced. Minkowski himself did not shout the philosophical consequence, but it sits right there in the mathematics, plain and waiting. If space-time is a complete 4-dimensional fabric, and your present is only one arbitrary slice through it, then the other slices, the ones you call the past and the ones you call the future, are made of exactly the same fabric, no less real than the slice you happen to be standing in. The loaf does not thin out behind you into non-existence. It does not fail to exist ahead of you. It is all there, all at once, and what we call the flow of time may be nothing more than our own slice, sweeping across a loaf that was never going anywhere. That reading has a name, and it is where we are going. But first we have to see how strange the slicing really gets, because it does something to the past and the future that almost no one expects. There is a way to make Minkowski's fabric a little more concrete, and it is worth the effort, because once you have it, the whole block universe stops feeling like mysticism and starts feeling like plain geometry. Physicists draw what they call a spacetime diagram, and though I cannot draw for you tonight, you can build one easily in your mind. Picture a single vertical line running up the middle of your imagination, and let that line stand for time, with the past low down and the future high up. Now let the horizontal direction stand for space, for how far left or right something is. A thing sitting still, not moving through space, simply endures through time, and so its world line is a straight vertical line, rising steadily upward as time passes while staying in the same place from side to side. A thing moving through space traces a line that leans over, tilting to one side as it rises, because as time carries it upward, it is also shifting sideways. The faster it moves, the more its world line leans, and light, in this picture, has a special role, because its speed is the one fixed thing everyone agrees on. Light traces lines tilted at a particular fixed angle, and because nothing can outrun light, nothing can ever tilt more steeply than those light lines. This gives every event a kind of cone reaching up into its future, the region of space-time it can possibly affect, and a matching cone reaching down into its past, the region that could possibly have affected it. Physicists call these light cones, and they are the true skeleton of causality in the universe. Anything inside your future light cone is a place you could, in principle, send a signal to or travel to. Anything outside it, off to the sides, is a region you can never reach or influence, no matter what you do, because to get there, you would have to move faster than light. And here is the thing that connects it back to our slicing. Those events off to the sides, the ones outside both your past and future cones, are precisely the ones whose ordering in time depends on your motion, the ones about which different observers disagree over what happened first, or whether they happened at once. Causality stays firm, cause always before effect for everyone, because those are linked inside the cones where all observers agree. But the vast elsewhere off to the sides, the events too far away to be causally connected to you right now, those are the ones the slicing scrambles, the ones that can lie in your present or your past or your future depending on nothing more than how you're moving. This is why the block universe follows so naturally from the geometry, and why so many physicists find it almost forced upon them. Once you have drawn space-time as a single fixed structure, with world lines threading through it, and light cones defining what can affect what, there is simply nothing in the picture that moves, nothing that flows, no special glowing line marking the true present creeping upward. The diagram is complete and static. Every event is just there, at its place, with its cones and its connections, and the whole of history is laid out at once like a landscape seen from above. The mathematics does not contain a flowing now. You can add one by hand, insist that some particular horizontal slice is the real present, and that it climbs steadily up the diagram, but the physics does not require it and does not provide it. And the moment you try to say which slice is the real one, relativity reminds you that observers moving differently would choose different slices and none has priority. So the flowing present becomes something you are importing from your intuition and laying over a geometry that neither needs nor supports it. The block is what is left when you stop importing it. That is the quiet, almost unsettling elegance of Minkowski's world. I want to give you a moment of history that makes Minkowski himself more than a name, because he came to this insight from an unexpected direction and did not live to see how completely it would reshape physics. He was a mathematician first and foremost, a man who saw the world through the lens of geometry, and it was that geometric eye that let him spot the pattern hidden in Einstein's physics. Where Einstein had thought in terms of clocks and light signals and observers comparing measurements, Minkowski looked at the resulting equations and saw shapes, saw that the whole tangle of relativistic effects was the natural behaviour of distances and angles in a four-dimensional geometry, if only you define distance in the right, slightly strange way. The strange way is this. In ordinary space, to find the distance between 2 points, you combine the separations in each direction, so that they always add to something positive, and moving in any direction always increases your distance from where you began. In Minkowski's spacetime, time enters the combination with the opposite sign from space, so that time and space partly cancel rather than simply adding, and this single sign difference, this one twist in the geometry, is the mathematical seed from which every relativistic strangeness grows. The time dilation, the relative simultaneity, the constancy of light speed, all of it. Minkowski gave his famous lecture on this in 1908, and within only a few months, at the start of the following year, he died suddenly of a burst appendix, still a young man before he could see relativity triumph or watch his four-dimensional world become the permanent language of modern physics. Einstein, who had at first been somewhat dismissive of what he saw as his old teacher's excessive mathematics, calling it superfluous learnedness, came in time to understand how essential Minkowski's geometric vision was and leaned on it heavily when he built his greater theory of gravity a few years later, the theory in which space-time not only holds events, but bends and curves and does the work that we feel as gravity. Without Minkowski's fabric, there would have been no supple four-dimensional cloth to bend. So the man who first saw time as a dimension, woven into a single geometry with space, the man who first gave us the loaf we've been slicing all night, did his great work and then was gone within the year, leaving the fabric behind for others to explore. There is something fitting, almost gentle in that. He glimpsed the timeless block and then took his own place within it, at his own fixed location in the fabric he had revealed, where, if the block is right, he remains. Let us take the loaf and the slicing and push on them until they yield the surprise they are hiding, because this is the step where the abstract geometry reaches out and touches the question we started with. Remember what a slice is. Your slice, your present moment, is the set of all events in the universe that you would judge to be happening right now. Not events you can see, since seeing is always seeing the past, but events you would calculate, after correcting for the travel time of light, to be simultaneous with this instant of yours. That calculated set of simultaneous events spread across all of space is your now, your slice through the loaf. Now here is the move that two thinkers, the Dutch physicist Cornelis Willem Rietdijk and, independently, the American philosopher Hilary Putnam, made explicit in the middle of the last century, and it is worth following step by careful step. Consider a friend standing across the room from you, at rest, not moving relative to you. You share a slice, your now and their now, for events out at some great distance, line up. Fine. But now let your friend begin to walk, gently, across the room and consider some event happening on a planet in a galaxy very far away, so far that light from it takes many years to cross the gap. Because your friend is now moving, even at walking pace, their slice through the loaf tilts, ever so slightly relative to yours. Over the enormous distance to that far galaxy, that tiny tilt sweeps across a great span of the distant world's history. And so the event on that faraway planet that lies in your friend's present, in their now, is not the same event that lies in yours. Their walking present out there might pick out an event that from your point of view has not yet happened, that lies in your future. Follow the chain all the way, because this is the quietly staggering part. The event in your friend's present is, for your friend, real and definite and happening now, as real as anything ever is. But that same event lies in your future, in the part of the loaf you would call not yet real. And your friend's present is just as valid as yours. There is no privileged slice. So if your friend's now is real, and it contains an event that is in your future, then your future must be just as real and just as fixed as your present, because it is somebody's present, sliced at a slightly different angle. And you can run the same argument the other way, with your friend walking in the opposite direction, and pull events out of your past into their present, showing that your past is equally real, equally there. The past and the future on this argument cannot be non-existent. They must be as real as now, because for someone moving differently, your past or your future simply is there now. This is called the Rietdijk-Putnam argument, and I want to be very careful and very honest with you about what it does and does not establish, because on this channel the honesty is part of the calm. What the argument establishes rests on premises that are themselves well tested. The relativity of simultaneity is not in doubt. The tilting of the slices with motion is not in doubt. The mathematics is not in doubt. What the argument then concludes, that the past and future are therefore just as real as the present, follows if you accept a further quiet assumption, which is that what is real for one observer must be real, in some absolute sense for all. That extra step from is real for someone to is real full stop is where the philosophy lives, and it is genuinely debated, and we will come back to those who resist it and how. But feel the force of it first, starting only from measured, uncontroversial physics and adding one very natural seeming assumption about reality being something all observers can agree on. You arrive at the conclusion that the moment you were born and the moment you will die, and this quiet moment now, are all equally real, all sitting in the loaf together, none of them privileged, none of them gone, none of them yet to come. Let that rest with you. You're lying there, and it feels as though this single moment is the only real one, the bright edge, and everything behind it has fallen away into nothing. But if the argument holds, the moment an hour ago when you settled in to listen is still there, in the fabric, exactly as real as this one, with you in it, settling in. And the moment tomorrow morning when you wake is also there, already, with the same solidity. Nothing has been lost. Nothing is waiting to be born. It is all simply there, and the sense that only this instant exists is like the sense that the earth stands still, a true report of how things feel from inside one slice, and a false report about the loaf as a whole. I said I would be honest, so let me hold the tension open rather than close it too soon. This argument has been challenged, and the challenges are serious, and we will give them their due before the night is over. Some say that the notion of what is real for a distant observer is not as simple as the argument needs it to be, once you remember that no observer can influence or even know about those distant events until light has had time to cross. Others hold on to the reality of only the present and pay the price in other ways. The debate is alive. But what is not in doubt, what you can carry with you as settled, is that the old comfortable river, the single universal present sweeping forward for everyone alike, does not survive contact with relativity. Whatever time turns out to be, it is not that. And the leading way physicists have of picturing what it is instead has a name we have been circling all night, and it is time, at last, to say it plainly and to enter it fully. But before we do, let us make sure the ground beneath all this is as solid as I have claimed, by looking at how we actually know that time bends and stretches and refuses to keep one universal beat. Because it would be fair lying there to wonder whether all this rests on thought experiments and chalkboards. It does not. It rests on clocks that have flown around the world. Let me add a little more care to the distant galaxy example, because the numbers, once you feel them, make the abstract argument suddenly vivid, and because I do not want you to think the tilting is some negligible thing that only matters at impossible speeds. The remarkable point, the one that startled people when Reitdijk and Putnam laid it out, is precisely that it does not take impossible speeds. It takes walking. The reason a gentle stroll can shift your present on a distant world by years is that the tiny tilt in your slice, utterly negligible over the distance of a room, gets multiplied by an enormous lever arm when the distance is enormous. A slice tilted by the faintest angle, extended across billions of kilometers or across many light years, sweeps up or down through a great span of time at the far end, the way a door swinging open by a hair's width at the hinge sweeps its far edge through a wide arc if the door is impossibly long. So over the distance to a far galaxy, the difference between your slice standing still and your slice tilted by your slow walk can amount to the far world's events shifting by years, in some tellings even by more than that when the galaxy is far enough. That is the leverage of cosmic distance acting on a tiny tilt. And so the argument, laid out step by step, is genuinely hard to escape if you grant its premises. 1. There is no privileged observer, no true present, only the observer-dependent slices, and this is settled physics. 2. Whatever an observer counts as happening now is, for them, real as anything. 3. Reality is not a matter of perspective in the way that being on the left or the right is, so if something is real for a valid observer, it is real. Full stop. Put those together and you get eternalism, because your walking friends now, sliced at its tilt, contains events in your future. Those events are real for your friend, and by the third premise they are therefore real, which means your future is real and the same runs for the past. The first premise is rock-solid physics. The second seems almost undeniable, since it merely says that what is present is real. It is the third premise, the one that says reality cannot be relative in the way simultaneity is, that carries all the philosophical weight, and it is precisely there that the defenders of the flowing present dig in, as we will see. But feel how little you have to grant to reach the block. You have to grant only the physics plus the very natural thought that what is real for anyone is simply real. From that small seed, the whole eternal landscape grows. I want to be honest that Putnam himself stated the conclusion with great confidence, treating it as though the physics had simply settled the metaphysics, and the philosophers who kept debating the reality of time were behind the times. Later thinkers have been more cautious, and rightly so, because that third premise turns out to be doing more work than it first appears, and reasonable people question it. But even the cautious ones tend to agree that the burden has shifted, that after relativity the old flowing present cannot simply be assumed as obvious, that anyone who wants to keep it now has to work for it and pay a price for it. The universe took the assumption we all make without noticing, the assumption of a shared moving now, and quietly declined to provide it. What we build in its place is up to us, constrained by the physics, and the block is the most natural thing the constraints allow. I said I would hold the tension open rather than close it, and part of that honesty is to name plainly where the third premise, the one carrying all the weight, can be resisted, because the resistance is real and it is not foolish. The premise said that reality cannot be relative in the way simultaneity is, that if something is real for a valid observer, then it is simply real. But a careful thinker can push back and say that the very word real, when stretched across the vast gulf to a distant galaxy, may not carry the solid meaning we imagine. What does it truly mean to say that an event on a world many light years away is real for you right now, when you cannot see it, cannot influence it, cannot be influenced by it, cannot in any way exchange a signal with it, because light itself has not had time to cross the gap in either direction? That distant event sits in the region. Relativity calls you elsewhere, the part of space-time causally cut off from your here and now, and some philosophers argue that reality for such events is simply not the kind of thing that has to be shared between observers, that it is meaningful only within a light cone, only where causal contact is possible, and that outside it the question of what is real right now loses its grip entirely. If that is right, then the Reitdijk and Putnam argument, elegant as it is, may prove less than it seems, because it leans on comparing what is real for you and what is real for your walking friend at distant, causally disconnected events. And if reality does not have to match across such gaps, the chain from your friend's now to your future being real is quietly broken. I lay this out not to knock the block down, because the block remains the most natural and widely held reading, but because you deserve to know that the door the argument seems to force open can be held partly shut by someone willing to be careful about the meaning of a single word. This is what the frontier actually looks like, up close. Not a wall between the known and the unknown, but a fine and honest disagreement about what our clearest words mean when we carry them to places light itself takes years to reach. And there is a deep calm in seeing that even here, at the sharpest edge of the question, the disagreement is gentle, precise, and unresolved, tended by thoughtful people who go home at night and sleep beside the same open question you are holding now. It is one thing to be told that time is relative, that clocks disagree, that simultaneity dissolves. It is another thing to know it the way we know the sun will rise, because we have measured it, over and over, with instruments of exquisite precision, and it has come out exactly as the theory said it would, every single time. So let us spend a little while on the measurement story, because on this channel, the method of knowing is often the most soothing part, the part that turns a strange claim into a settled companion you can rest against. The heart of relativity's claim about time is that a clock's rate depends on how it moves and where it sits. A clock that travels fast runs slow compared to one at rest. A clock deeper in a gravitational field, lower down, closer to a massive body, also runs slow compared to one higher up. These are not effects on the mechanism of the clock, not some pressure or jostling that throws off the gears. They are effects on time itself, on the very rate at which duration passes for that clock. Any clock of any kind, a pendulum, a quartz crystal, a beating heart, a vibrating atom, All of them shift together because it is time that shifts, not the device. This is called time dilation, and for most of history it was utterly beyond our power to detect, because the effects at ordinary speeds and ordinary heights are almost unimaginably small. But our clocks have become almost unimaginably good. The most beautiful early demonstration came in 1971 in an experiment so simple in concept that it delights everyone who hears it. Two physicists, Joseph Hafele and Richard Keating, took atomic clocks that keep time by counting the incredibly steady vibrations of cesium atoms, and they did something almost comically direct. They bought seats on ordinary commercial airliners, buckled their clocks in, and flew them around the world, first eastward, then westward, while identical clocks stayed behind on the ground at the Naval Observatory. Then they brought the flown clocks home and compared them to the ones that had stayed. If relativity was right, the travelling clocks and the stationary clocks should no longer agree. They should have ticked away slightly different amounts of time during the journey, and they had. The differences were tiny, measured in billionths of a second, a matter of tens of nanoseconds, but they were there, and they matched the predictions of relativity, both the shift from motion and the shift from altitude, to within the precision of the experiment. The clocks that flew had genuinely lived through a slightly different amount of time than the clocks that stayed. Let that settle for a moment. Not the appearance of a different time. A different time. Two clocks that began in step, parted, travelled different paths through space-time, and came back no longer agreeing about how much time had passed, because for each of them, a different amount genuinely had. The twin who journeys and the twin who waits are not a paradox to be resolved away. They are in miniature in nanoseconds a measured fact. If that experiment feels distant and academic, consider that you very likely carry its consequences in your pocket and rely on them whenever you find your way. The system of satellites that lets a phone know where it is on the Earth works by timing, with fantastic precision, how long signals take to arrive from satellites high overhead. Those satellites carry atomic clocks, and they are both moving fast in their orbits and sitting high up out of the thickest part of the Earth's gravity. Both effects shift their clocks relative to clocks on the ground, in opposite directions and by different amounts, and the net result is that a satellite clock and a ground clock drift apart by a small but absolutely critical amount every single day. If the system did not correct for this, if it treated time as universal and unchanging the way our intuition does, the position it reported would drift off by kilometres within a day, and the whole thing would be useless. It works, it guides ships and aircraft and lost travellers home, precisely because the engineers who built it took relativity's picture of time as literally true and built the corrections in. Every accurate location a phone has ever given you is a quiet daily confirmation that time is not universal, that it bends with motion and with gravity, exactly as Einstein said. So when I ask you to accept that simultaneity is relative, that there is no single shared now, that the slicing of space-time into presence is genuinely observer-dependent, I'm not asking you to trust a chain of clever reasoning alone. I'm asking you to trust the same physics that flies clocks around the world and finds them disagreeing, the same physics that steers you home through the dark. The strangeness is not a speculation bolted onto solid science. It is the solid science. The clocks really do disagree. Time really does stretch. The universal present really is gone. And that means the question we have been holding, whether the past still exists, cannot be waved away as mere philosophy. It grows directly out of the most tested physics we have. Which brings us at last to the picture that this physics most naturally suggests, the picture we have been slowly assembling all night without yet naming it in full. It is time to step inside the block. There is more to the measurement story, and it is worth telling, because the confirmations of relativity's strange time are not a single lucky experiment, but a great accumulating weight of them, from the largest scales to the smallest, all pointing the same way. Long before Hafele and Keating flew their clocks, nature was already running the experiment for us, constantly, in the upper atmosphere. When cosmic rays, fast particles from deep space, strike the top of the atmosphere, they produce showers of tiny particles called muons, which are a kind of heavy cousin of the electron. These muons are unstable. Left to themselves at rest, they survive for only a couple of millionths of a second before they decay, and travelling even at nearly the speed of light, that brief life should let them cover only a few hundred meters before they vanish. By that reckoning, Almost none of them should ever reach the ground, tens of kilometers below where they are made, and yet they arrive at the surface in great numbers, far more than should survive the trip. The reason is time dilation. The muons are moving so fast that their internal clocks, from our point of view, run slow, stretching their brief lives enough that they can cross the whole atmosphere before decaying. From the muon's own point of view, its life is as short as ever, but the atmosphere rushing up to meet it is contracted thin enough to cross in time. Either way you slice it, the muons reach the ground, and they reach it in exactly the numbers relativity predicts. Every rain of muons through your body, every second, is a confirmation, and the precision has only deepened. Modern atomic clocks have grown so fantastically accurate that they can now detect time dilation not from flying around the world, but from being raised or lowered by tiny amounts, or moved at the speed of a slow walk. Physicists have taken two of the best clocks, placed them side by side, and then lifted one of them by a modest height above the other, and watched the raised clock tick very slightly faster than its neighbour below because it sits a little higher out of the Earth's gravity, exactly as the theory says. The difference so small it corresponds to the height of a person or less, and yet there it is, measured, real. They have accelerated clocks at the gentle speeds of everyday motion and caught the slowing. There is now no serious room for doubt. Time is not universal. Its rate depends on motion and on gravity, at every scale we can reach, from muons born in the sky to cesium atoms flown on airliners to clocks lifted a hand's breadth in a laboratory. The whole edifice hangs together, and it hangs together only if the universal present, the single shared now, is given up. So the strangeness we have been building toward is not the fragile speculation it might have seemed. It is the most robustly confirmed physics we possess, confirmed 1,000 times over, woven into the machinery of daily life, and it leaves us, whether we are comfortable with it or not, in a universe with no single flowing present. I want to give you one more piece of the measurement story because it turns the strangeness of relative time into something almost tender, and it is the piece people remember longest. It is the matter of the twins, and it is not merely a thought experiment but a measured reality, played out every day in the lives of particles and clocks. Imagine two people who begin together, side by side, their clocks in perfect step. One of them stays home, the other travels away at great speed far out into space, then turns and comes back. When they are reunited, the traveller has aged less than the one who stayed. Not seemed to age less, aged less. Fewer heartbeats, fewer breaths, less life elapsed, because the path they took through space-time was, in the precise geometric sense the theory gives, a shorter path in time. This sounds like a paradox, and for a century people have delighted in puzzling over it, but it is no paradox at all once you see it as geometry. In ordinary space, a straight line is the shortest distance between 2 points, and a wandering path is longer. In space-time, curiously, it works the other way for time, and the straight, unaccelerated path between two events, the path of the one who stays home, turns out to carry the most elapsed time, while the bent path of the traveller who accelerates away and back carries less. The amount of time each person actually lives is just the length of their own particular thread through the fabric, measured along the thread itself, and different threads between the same 2 points can have genuinely different lengths. Physicists call the time elapsed along a given world line its proper time, and it is one of the deepest and most beautiful ideas in all of relativity. There is no single, true time between two events. There is only the time measured along each particular path, and different paths give different answers, all of them equally real. Let that settle, because it says something quietly profound about the block. If the amount of time you experience is the length of your own thread through space-time, then time is not a river you float on but more like a distance you travel, a distance that depends entirely on the route you take. Two people can leave the same moment and arrive at the same later moment having lived different amounts, the way two travellers can leave the same city and arrive at the same distant city, having driven different numbers of miles by taking different roads. Time becomes something more like a landscape to be crossed than a current that carries everyone alike. And a landscape, unlike a current, is simply there, all of it, its valleys and its distances laid out in advance, waiting to be crossed by whoever passes through. The proper time of your life is the length of your particular road through a country that already, in the fullest sense the physics allows, exists. There is a subtlety here worth pausing on, because it seems at first to give the universal present back to us, and understanding why it does not is one of the most illuminating steps of all. When astronomers survey the whole universe on its largest scales, they find that it does, after all, single out one special state of motion, one preferred frame of reference. It is the frame in which the faint afterglow of the early universe, the ancient light that fills all of space left over from the cosmos's fiery beginning, looks the same in every direction, without the slight warming ahead and cooling behind that motion through it would produce. Everything drifting along with the general expansion of the universe shares roughly this frame, and it lets cosmologists speak sensibly of the age of the universe, of how long it has been since the beginning, a single number, some 14 billion years, that they can state for the cosmos as a whole. So there is in a sense a cosmic time, a preferred slicing that the universe itself seems to prefer, and you might think this quietly restores the universal now we lost. But it does not, and the reason is precise and important. That cosmic frame is special only in a practical, contingent way, because of how the matter of our particular universe happens to be spread out and moving, not because the laws of physics single it out as the true rest. Relativity still holds underneath. An observer moving relative to that cosmic frame is doing nothing forbidden, breaking no law, and their slicing of time is every bit as physically valid as the cosmic one. The cosmic frame is a convenient reference, like agreeing to measure all altitudes from sea level, not a discovery that sea level is the true bottom of reality. So the universal present is not restored. What we have is a useful, agreed-upon frame for the universe as a whole, born of the particular arrangement of its contents, sitting on top of a physics that still refuses to name any present as the real one. A presentist can seize on this cosmic frame and say, there, that is the true now, and we met that move earlier and saw that it has a coherent form. But relativity itself does not compel it. The deep structure still offers no privileged slice. The cosmic frame is a fact about our universe's furniture, not about the nature of time, and the block stands where it stood. Here it is then, the picture the physics has been quietly drawing for us since the moons of Jupiter first ran late. It is called the block universe, or eternalism, and it is, among physicists who think about the nature of time, one of the most widely held ways of understanding what relativity is telling us. The idea is this: the whole of space-time, every event that has ever happened and ever will happen, exists as a single, complete four-dimensional whole. The past, the present, and the future are all equally real, all equally there, laid out together in the great loaf of space-time, and none of them is privileged. There is no special moving present that is more real than the rest. There is no flowing river. There is only the block, entire and unchanging, and every moment sits within it forever, exactly where it is. On this view, the moment of your birth is not gone. It is still there, at its place in the block, as real as it ever was, with the light in the room and the first breath, and everyone who was present, all still there, fixed in the fabric. The moment you are living right now is there too, this one, with you lying in the quiet listening. And the moment of your death, whenever and however it comes, is also already there, waiting at its own place in the fabric, no more and no less real than any other. Nothing is coming into existence. Nothing is passing out of existence. The block simply is, all of it at once, and what you experience as the flow of time, the vivid sense of one moment becoming the next, is something happening within the block from the inside, along the thread of your own world line, not a real movement of the block itself. This is the withheld thing I promised you at the very beginning, when I said there is a way of reading our best physics in which you have never once left any moment you have lived. Now, you can see what I meant. If the block universe is right, then leaving a moment is not something that happens. The moment does not fall away behind you into nothing. You're simply strung out along your world line, present at every moment you ever occupy, all at once from the outside view, even though from the inside, from within any single slice, you feel only that one instant and remember the ones before it, and cannot yet see the ones ahead. The child you were is still there, in that afternoon, in that light. The person you will be tomorrow is already there, in that morning. You are, in the fullest four-dimensional sense, all of them together, a single, long shape in the fabric, and no part of you is ever truly lost. I want to hold this gently, because it can be read two ways, and one of them is cold, and one of them is warm, and I think the warm reading is both truer to the physics and kinder to a person lying in the dark. The cold reading says, If the future already exists, then everything is fixed, and we are trapped, merely travelling along a track that was laid down before we started, with no freedom and no say. But that is not quite what the block requires, and it imports a fear that does not belong. Your choices are still your choices. They are woven into the fabric as part of what you are, part of your world line. The block being complete does not mean something outside you decided your life. It means your life, including every real choice you make and the deliberation you put into it, is all there, all part of the pattern, authored from the inside by you living it. Nothing is reaching in to move your hand. You're simply, fully, present throughout your own existence. And the warm reading is this: nothing you have loved is utterly gone. The moments that felt most alive, the ones you look back on with the ache of their passing, the sense that they are lost forever, that ache rests on the river picture, on the belief that the past has fallen away into non-existence. But if the block is right, those moments have not fallen anywhere. They are still there, held in the fabric of reality, as real and as bright as they ever were, permanent features of the universe that no passage of time can erase, because there is no passage of time in the sense we feared. What is done is not undone, but neither is it annihilated. It is kept. The universe, on this reading, is not a river that carries everything away. It is a vast and permanent landscape, and we are travellers who can see only the ground beneath our own feet, mistaking our walking for the world rushing past and vanishing behind us. Now, I must be as careful here as anywhere in this whole night, because it would be a betrayal of the channel and of you to state the block universe as settled, proven fact. It is not. Let me draw the line clearly in plain words. What is settled, tested, and beyond reasonable doubt is the physics underneath it. The relativity of simultaneity is settled. Time dilation is settled. The absence of a universal, observer-independent present is settled. The four-dimensional geometry of spacetime is settled. The working language of modern physics, that is the solid ground. What is not settled, what remains a matter of genuine and lively debate among thoughtful physicists and philosophers, is the further step of saying that this geometry means the past and future are as real as the present, that eternalism is the correct account of what exists. That is an interpretation. It is a very natural interpretation, arguably the most natural one held by many, defended with real force. But it is not the only one, and it cannot be read directly off an instrument the way time dilation can. Reasonable, well-informed people look at exactly the same, settled physics and come to different conclusions about what it means for the existence of past and future. And that, far from being a source of unease, is one of the loveliest things about this whole question, and it is where we turn next. Because if the block is complete and unchanging, there is one enormous thing it seems to leave unexplained, one thing you are doing at this very moment that the block, on its face, cannot account for. You are experiencing the passage of time, and no one fully agrees on why. Let me dwell inside the block a little longer before we complicate it, because there is a particular way of feeling it that I think is worth carrying to sleep, and it comes from one of the tenderest moments in the history of this idea. When Einstein's lifelong friend Michel Besso died, in the year 1955, Einstein himself only weeks from his own death, he wrote a letter of condolence to Besso's family, and in it he set down a thought that has been quoted ever since, because it shows a great physicist reaching for the human meaning of the block. He wrote that for those of us who believe in physics, the distinction between past, present and future is only a stubbornly persistent illusion. He did not mean it coldly. He meant it, I think, as a kind of consolation, a way of saying that his friend had not truly vanished, that in the deeper reckoning of physics Besso was still there, at his place in spacetime, his life complete and permanent and real, not erased by the mere fact that Einstein's own present had moved on past it. Whether Einstein was entirely right is exactly the open question we're circling, and we must not pretend his authority settles it. But the feeling in that letter is the warm reading of the block made personal, offered by the man who did more than anyone to reveal it, to a grieving family at the end of his own life. And there is a further subtlety worth holding, one that keeps the block from feeling like a prison. Notice that in all of this, nothing about the block universe says the future is knowable. It may be entirely real, fixed in the fabric, and yet completely unknown to you because you are inside the block, threaded along your world line, and you cannot see ahead any more than a figure painted at one edge of a vast mural can see the far side of the painting. The future existing and the future being predictable are two entirely different things, and the block only claims the first. From inside, life is exactly as surprising, exactly as open to your effort and your choice, exactly as uncertain as it has ever felt. You still do not know what tomorrow holds. You still shape it by what you do today. The only thing that changes, if the block is right, is the metaphysical status of it all, the quiet fact that the tomorrow you're shaping is, in some sense, already there to be shaped, woven into a fabric that includes your shaping of it as one of its own threads. Your ignorance of the future is complete and genuine. Your influence over it is real. What the block adds is only that none of it is ever truly lost, that the real, so to speak, exists in full, even though you can only ever watch it one frame at a time and can never skip ahead to see how it ends. There is one more thread I owe you here, and it is perhaps the most startling of all, a piece of settled mathematics that takes the reality of the past from a matter of interpretation to something almost tangible. In the year 1949, the logician Kurt Gödel, who was among the closest friends Einstein had in his final years at Princeton, the two of them famously walking home together in long conversation, gave Einstein a birthday gift unlike any other. He gave him a solution to the equations of general relativity, Einstein's own theory of gravity, describing a possible universe, a universe that rotates as a whole. And in Gödel's rotating universe, the equations permit something extraordinary. They permit paths through space-time that loop back on themselves, world lines that, if you followed them far enough, would return you to your own past, to an earlier moment of your own life, a genuine closed loop in time. Physicists call these closed time-like curves, and Gödel had shown, with the full rigour of mathematics, that Einstein's theory of gravity does not forbid them. In such a universe, the past would not merely still exist in some abstract philosophical sense. It would be a place you could, in principle, travel back to and revisit, as real and as reachable as a distant city. Now I must be careful and honest, because the honesty is the point. Gödel's rotating universe is almost certainly not our universe. Our universe does not appear to rotate in the way his solution requires, and there are deep reasons to think that the kinds of time loops he found do not actually occur in the cosmos we inhabit. So this is not me telling you that you can travel to your childhood. What Gödel showed, and what shook Einstein when he received it, is something subtler and in its way more profound. He showed that the very structure of our best theory of space, time and gravity contains no built-in principle that makes the past unreal or unreachable. The reason we cannot revisit the past is not written into the foundations of physics as some absolute law. It is a contingent fact about the particular universe we happen to live in, about how its matter is arranged and how it does or does not rotate, not a necessary truth about time itself. Gödel took this as evidence for the block, for eternalism, arguing that if the past can, in some possible universe consistent with the same physics, be revisited as a place, then the past must be the kind of thing that exists, a place, and not a nothing, for otherwise there would be nothing there to revisit. The mere possibility allowed by the equations that a universe could loop back to its own past tells you something about what the past fundamentally is. It tells you it is real enough to be a destination. And that, resting in the same equations that steer satellites and bend starlight, is about as close as settled physics comes to whispering that the past is still there. Before we leave the block and turn to what it cannot explain, let me sit with you a little longer on the worry that troubles almost everyone when they first meet this idea, the worry about freedom, because I do not want to leave it merely waved away. The fear goes like this. If the future already exists, fixed and complete in the fabric of space-time, then surely everything I will ever do is already settled, and my sense of choosing, of deliberating, of making a real difference is a hollow illusion, and I am merely a passenger on a track laid down before I was born. It is a natural fear, and it deserves a real answer, not a dismissal. And the answer, I think, is that the fear smuggles in a picture that the block does not actually contain, the picture of the future being fixed by something other than you, fixed in advance, imposed from outside, so that your choosing is bypassed. But that is not what the block says. In the block, your deliberation is there, your weighing of options is there, your choice is there, all of it woven into the fabric as a genuine part of the causal order, and the future is what it is precisely because of those choices, not in spite of them. Nothing reaches in from outside the block to overrule you. Your choices are not sidestepped on the way to a predetermined outcome. Your choices are among the threads from which the outcome is made. Think of it this way. A story that is already written from beginning to end still has its characters make their choices within it, and those choices still drive everything that happens, still matter completely to the shape of the tale, even though the whole tale exists at once as a finished thing. The characters are not robbed of their agency by the book being complete. Their agency is written into the completeness. The difference, and it is the crucial one, is that in the block there is no author standing outside who decided it all in advance. You are, from the inside, the author of your own thread, and the fact that the thread exists in full does not mean someone else drew it. It means you drew it, are drawing it, will have drawn it, all of those tenses collapsing into the single truth that your life, choices and all, is a real and self-authored part of the fabric. Whether this fully satisfies the ancient worry about freedom is itself one of the great open questions of philosophy, older than physics and unlikely to be closed by it, and I will not pretend to settle it for you tonight. But I can at least free you from the particular nightmare of the puppet on a predetermined string, because that nightmare requires a puppeteer, and the block contains none. There is only you and your life and the strange dignity of being a complete and permanent thing that nonetheless, from the inside, chooses. Here is the puzzle that the block universe hands us, and it is a real one, not a manufactured mystery. If all moments exist equally, if the block just sits there entire and unchanging, then why does time feel as though it flows? Why is there this overwhelming, undeniable sense of one moment giving way to the next, of the future rushing toward us and the past receding behind? Why do we feel ourselves moving through time at all, if there is nothing to move through, and no movement to speak of? A block does not flow. And yet here you are, lying in the dark, feeling the seconds pass, feeling this night unspool. Something must account for that feeling, and the block by itself does not obviously do so. This is where physics reaches one of its most honest and interesting frontiers, and I want to walk through it slowly and mark clearly what is understood and what is not. Part of the answer, the part we understand well, has to do with a deeper symmetry in the universe called entropy, and with the arrow it provides. Entropy is, roughly, a measure of disorder, of how many ways the pieces of a system could be arranged while looking much the same. A neatly stacked deck of cards is in a very orderly low-entropy state, one specific arrangement. Shuffle it, and it tumbles into disorder, into one of the overwhelmingly many jumbled arrangements, high entropy. And here is the key fact. Left to themselves, systems move from order toward disorder, from low entropy toward high, essentially always, simply because there are so many more disordered arrangements than orderly ones that a system stumbling blindly among its options will almost certainly find itself more disordered a moment later. A cup of hot tea cools to room temperature and never spontaneously reheats. An egg breaks and never unbreaks. Smoke spreads through a room and never gathers itself back into a tidy plume. This gives time a direction, a genuine physical difference between the way toward the past and the way toward the future. The past is the direction of lower entropy, of more order. The future is the direction of higher entropy, of more disorder. Almost everything we mean by the difference between past and future, the fact that we remember the past and not the future, that causes come before effects, that we can affect the future but not the past, traces back to this single vast slope of entropy running through the universe. Running because, for reasons still not fully understood, the universe began in an extraordinarily orderly, low-entropy state, and has been unfolding toward disorder ever since. That much is settled science. The arrow of time, the objective difference between the two directions, is real, and it comes from entropy and from the strangely ordered condition of the early universe. But notice, and this is the subtle and beautiful point, that an arrow is not the same as a flow. Entropy explains why the two directions of time are different, why past and future are not mirror images, why you remember one and not the other. It gives time a direction. But it does not, at least not obviously, explain why we feel ourselves moving along that direction, why there is a vivid travelling present that seems to advance. A signpost pointing north is not the same as walking north. The arrow tells us which way is future. It does not by itself tell us why we seem to be sailing that way, why now feels like it is perpetually sliding forward. And here, past the edge of what is settled, Physicists and philosophers genuinely part ways, and I will lay the main paths before you as gently as I can, all of them flagged clearly as open, none of them the final word. One view, held by many who take the block seriously, is that the flow of time is not a feature of the world at all, but a feature of us, of how a conscious creature embedded in the block, with memory, necessarily experiences its own world line. On this view, at every moment along your thread, you have memories of the moments before and none of the moments after, because of the entropy arrow. And so from the inside, every moment feels like the leading edge, the freshest point, with a remembered past behind it. String those together, and you get the powerful illusion of moving forward, when really you are simply present at each point along a static thread, each point equipped with its own memories pointing backward. The flow, on this account, is real as an experience, but not as a physical happening. It is what the block feels like from inside, along a line of increasing entropy, for a being that remembers. This is an elegant idea, and it may well be right, but it is not proven, and it leans on our still incomplete understanding of consciousness and memory, which is a frontier all its own. Another family of views is not so willing to give up the flow, and holds that our experience of time passing is telling us something real that the block picture leaves out, that a complete physics will have to add something, some genuine becoming, some real coming into being of new moments that the bare block does not contain. Thinkers in this camp suspect that eternalism, for all its elegance, has quietly discarded something essential about time, mistaking the map, the four-dimensional geometry, for the territory, the lived unfolding reality. They may be right too. No experiment has yet settled it, and it is not clear what experiment could. Whether the passage of time is a real feature of the universe, or a feature of our experience of the universe is, at present, genuinely open. One of those deep questions at the seam between physics and philosophy, where the honest answer is that we do not yet know, and where saying so is not a failure, but the truth. And there are others still who suspect the whole framing will shift again when we finally understand how space-time itself behaves at the smallest scales, where our current theories of the very large and the very small have not yet been reconciled, and where time may turn out to be not fundamental at all, but something that emerges from a deeper layer that does not contain it. That too is open, wide open, and we will not pretend otherwise. I want to add one more layer to the puzzle of the flow, because it connects to something you can feel in your own body as you lie there, and because it marks how genuinely unfinished this corner of understanding is. Consider that the entropy arrow, the slope from order toward disorder, is what makes memory itself possible. To remember something is to hold a record of it, and a record is a piece of order, a low entropy trace left behind by an event, footprints in sand, a photograph, a pattern of connections laid down in the brain. Records can exist of the past because the past was more ordered, because the slope of entropy runs downhill from then to now, leaving traces along the way. There can be no records of the future for the same reason. There are no footprints ahead of the walker, because the order that would constitute such a record has not yet been laid down. So the very asymmetry of memory, the plain fact that you remember your childhood and not your old age, that you know where you have been and not where you're going, rests on the entropy arrow. And this is why, from inside, each moment feels like the leading edge. At every point along your world line, you carry records of the lower entropy direction and none of the higher entropy direction, and so every moment presents itself as a fresh present with a known past behind it and an unknown future ahead. And the stringing together of all these moments, each feeling like the edge, produces the sensation of continuous forward motion. But here is where honesty requires me to stop and mark the edge of the map clearly. Everything I just said explains the direction of time, the asymmetry, why past and future differ, why we remember one way and not the other. It is elegant and it is largely settled. What it does not explain, what nobody has yet explained to universal satisfaction, is the felt flow itself, the sense of movement, the vivid quality of nowness, the way this moment seems lit up and rushing. You can have a perfectly good account of why the two directions differ without having any account at all of why there seems to be a moving spotlight of the present travelling along the world line at all. The asymmetry is a fact about the structure, the flow is a fact about experience, and the bridge between them, The question of why a structure with a built-in direction should be experienced from the inside as a flowing present remains genuinely open, tangled up with the deepest unsolved questions about consciousness itself, about why there is any inner experience at all. So when I tell you that many physicists regard the flow as an artifact of how we are embedded in the block, I am reporting a serious and elegant view, but I'm not reporting a settled result. It is a frontier. The honest position, the one I want to leave you resting on, is that we understand with great confidence why time has a direction, and we do not yet understand with anything like the same confidence why it feels as though we move along it. That gap is real, and it is one of the genuinely open questions at the heart of physics, and there is no shame and much beauty in leaving it open tonight. There is a way of naming this open question that I find especially calming, and it comes from the physicists and philosophers who have thought hardest about the arrow of time in recent decades. They draw a careful distinction between three things that we usually bundle together and call, loosely, the flow of time, and pulling them apart makes it much clearer what is settled and what is not. The first is the plane asymmetry, the fact that past and future differ, which we have traced firmly to entropy and the ordered early universe. That is settled. The second is the direction of that asymmetry, which way is future, and that too follows from entropy, from the slope running from order toward disorder, also settled. But the third thing, the one that causes all the trouble, is the sense of passage itself, the feeling that the present is moving, that time is actively flowing, that now is sweeping forward like a spotlight along the world line. That third thing does not obviously come from entropy at all, and it is not clear that it comes from any feature of the physical world rather than from the nature of experience, and it is there at that third thing that the honest disagreement lives. Some of the most thoughtful voices in physics have argued that this third thing, the felt passage, is where we have been fooling ourselves, mistaking a fact about our own minds for a fact about the universe, projecting the movement of our attention onto a space-time that does not itself move. Others insist with equal seriousness that a feeling this universal and this vivid is unlikely to be pure illusion, that it may be a genuine clue to something our physics has not yet captured, a piece of reality that the timeless block leaves out, and that a deeper theory will have to restore. I cannot tell you tonight which of them is right, and neither can they tell each other, and that is not because anyone is being lazy or unclear. It is because we have reached, on this particular question, the real and present limit of human understanding, the place where the map simply stops, and the honest thing to write at the edge is here we do not yet know. There is something wonderful about being able to walk right up to that edge, in a matter as intimate as the passing of your own moments, and to stand there in the dark and look out at the not yet known, and to feel not fear but a kind of spacious wonder, the wonder of a question so deep that the finest minds alive are still leaning over it beside you. It would be easy, having come this far, to leave you with the impression that the block universe has simply won, that all serious thinkers have settled into it, and only the details of our felt experience remain to be tidied up. That would not be honest, and honesty here is a kindness, so let me bring into the room the ones who disagree, and let me give them their real strength, because the disagreement is live, and it is held by careful people. Picture, if you like, a room full of thoughtful physicists and philosophers, all looking at exactly the same settled physics, the same relativity, the same clocks, the same geometry, and describing what it means in genuinely different ways, each with reasons, none of them foolish. There are the eternalists, whom we have spent the night with, holding that past, present, and future are all equally real, the block complete. Against them stand the presentists, who have not surrendered, and who hold, still, that only the present is real, that the past has genuinely ceased to exist, and the future has genuinely not yet come. You might think relativity simply refutes them, given all we have said, and the challenge is certainly severe. But the thoughtful presentist has replies. Some argue that the relativity of simultaneity shows only that we cannot know or agree upon a universal present, not that there is none, and they are willing to entertain that there may be a real, privileged present that the physics simply does not reveal to us, a true now hidden behind the observer-dependent slicing. This costs them something. It means positing a real present that no experiment can detect, which many find too high a price. But it is not incoherent, and some serious philosophers of physics defend versions of it with care, sometimes connecting it to interpretations of quantum mechanics that seem, to them, to hint at a preferred slicing of time after all. Whether that hint is real is itself unsettled. And between the two stands a third view, quieter and rather lovely in its own right, called the growing block. On this picture, the past is real and the present is real, both of them there in the fabric, but the future is not yet real, has not yet come into being. The block exists, but it grows, accumulating new slices at its leading edge as time passes, the past forever kept and the future forever open, being written into existence moment by moment at the growing face of reality. It tries to honour both the sense that the past is fixed and permanent, and the sense that the future is genuinely open and not yet settled, that the block is still being built. It has its own difficulties, especially with relativity and the question of where exactly the growing edge is if there is no universal present. But it captures something many people feel very strongly, that the past is solid and the future is not, and it keeps that intuition alive within a serious framework. I lay these three before you not to leave you lost among them, but to show you something true and calming about the state of our knowledge. On the settled physics, there is no disagreement worth the name. The relativity of simultaneity, time dilation, the four-dimensional geometry of space-time, these are shared ground, agreed by everyone in that room, tested past reasonable doubt. The disagreement is entirely about what the settled physics means for the deepest question of all, whether the past and future exist. And that disagreement is not a scandal, not a sign that physics has failed, not a problem waiting for the one clever experiment that will banish all but one view. It may be that no experiment can decide it, that the question of what exists, as opposed to what we can measure, lies partly beyond the reach of measurement and touches something more like metaphysics, the oldest questions dressed in the newest mathematics, and there is a deep peace available in that if you let it in. You are allowed to lie here holding the question open. You do not have to close it tonight. The finest minds who have given their lives to it have not closed it, and they rest anyway. Let me give the dissenting views a little more of their due, because a fair map of the disagreement is one of the most calming things I can offer, and because the strongest versions of these positions are genuinely worth knowing. The presentist who wishes to keep the flowing now, faced with relativity, has essentially two honest paths, and thoughtful people have walked each. The first is to accept that there is a real, privileged present, a true now, but that relativity simply hides it from us, that the observer-dependent slicing is a limit on our knowledge rather than a fact about reality. On this path, the universe really does have a preferred way of dividing time from space, a cosmic present ticking forward, but the physics is arranged so that no experiment can ever reveal which slicing is the true one, so that every observer's own slicing works equally well for all practical purposes even though only one is really correct. This is not as arbitrary as it sounds, because our best cosmology does in fact single out one special frame of reference on the largest scales, the frame in which the ancient light left over from the early universe looks the same in every direction, the frame in which the universe as a whole is at rest. A presentist can point to that cosmic frame and say, there, that is the true present, the real now of the universe, even if local relativity cannot detect it. The price is admitting a reality that no measurement can reach, and many find that price too steep, but it is a coherent and seriously defended position. The second path some take is to look toward quantum mechanics, which in certain of its interpretations seems to want a preferred notion of now, a real moment at which possibilities become actual, at which the open future collapses into the settled past. There is a genuine and unresolved tension between the smooth, timeless, block-like picture that relativity suggests and the sharp, dynamic, becoming flavoured picture that some readings of quantum theory suggest, a tension that runs right through the unfinished project of uniting the two great theories into one. Some thinkers suspect that when that union finally comes, when we understand how space-time behaves at the smallest scales, the block may soften and something like real becoming may return, or the whole framing may transform into something neither side quite anticipated. Others suspect the opposite, that time will be revealed as even less fundamental than we now think, an emergent appearance arising from a deeper reality that contains no time at all. Both of these are live possibilities at the true frontier, and I raise them not to unsettle you, but to show you how open the deepest questions remain, and how the block universe, natural and beautiful as it is sits within a larger unfinished conversation rather than closing it. The growing block view, meanwhile, keeps trying to hold the middle, and its defenders have grown more sophisticated over the years in answering the relativity objections, proposing careful accounts of how a block might grow without needing a single universal edge, though none of these has won general agreement either. The room stays full, the conversation stays open, and that, I promise you, is a feature and not a flaw. I find one more image helpful for holding all three views at once without strain, and I offer it to you as we near the end. Imagine that a great and beautiful event has taken place, and that afterward a room full of thoughtful witnesses is asked to describe what is real about it now. One says the whole event exists, permanently, complete, and always will, kept in the fabric of what is. Another says only this present instant is real, the event itself long gone, real once and now nothing but a trace. A third says the event is real and kept, part of a growing store of settled past, while whatever has not yet happened remains genuinely open and unmade. Each of them is looking at exactly the same event, the same undisputed facts, the same physics, and each describes its reality differently. And the astonishing thing, the thing worth carrying to sleep, is that no measurement any of them could ever make would settle which description is correct. Their disagreement is not about anything they could point to and check. It is about what the settled facts mean for the deepest category of all, the category of what exists. And so we arrive at a resting place that is honest and, I think, quietly beautiful. On everything that can be measured, there is agreement and there is certainty. Light has a speed. Simultaneity is relative. Time stretches and bends. Spacetime is one four-dimensional fabric. The universal present is gone. On what all of that means for whether the past still exists, there is genuine, careful, unresolved disagreement, and there may always be. You're allowed to find that unsettling, but I hope lying here, you find it something closer to spacious, the way a large, quiet room is spacious, or a clear night sky. The question is big enough to hold you without pressing on you. You can lay it down beside you and let it keep, and it will still be there in the morning, and so, in one reading of the Physics at least, will this very moment, kept in the fabric, real forever, whether or not you ever return to see it. So let us gather the threads now, softly, the way you gather a blanket up around you before sleep. We began with starlight, with the plain and lovely fact that everything you see is the past arriving, that seeing is always seeing what was, because light takes time to cross the space between there and here. We followed that finite speed of light back to a patient astronomer, watching the moons of Jupiter run late, and we found in those tardy eclipses the first crack in the idea that anything happens instantly, anywhere, for everyone at once. From that crack we followed the widening fracture through Einstein's lightning and his moving train, and we watched the universal present come apart in our hands, watched two honest observers disagree about what happened at the same time with neither of them wrong. We saw Minkowski gather the pieces into a single four-dimensional fabric, space-time, one whole cloth in which every event sits at its fixed place, and we learned to slice that loaf at different angles and to see that no slice is the true one. We pushed the slicing until it showed us that one person's present can hold another person's past or future, and we let that lead us, by careful steps, into the block, the picture in which all moments exist together, permanent and complete. And we have been honest all along about what is solid and what is open, because that honesty is the deepest comfort this channel has to offer. Let me lay it out one last time, plainly, so you can carry it with you into sleep. It is settled, tested, woven into the technology you use every day, that there is no single universal present, that simultaneity depends on motion, that time stretches and bends and keeps no one master beat. That much is not in doubt and will not be taken back. What remains open, genuinely and perhaps permanently open, is what this means for the oldest question, whether the past and the future truly exist. The block universe says they do, all of it equally real, and it is perhaps the most natural reading of the physics, held by many. The presentist says only now is real, and pays a real price to keep that. The growing block says the past is kept and the future is still being written. And no experiment we now have, and perhaps none we ever will have, can reach in and tell us which of them describes what truly exists. That is where honest science leaves the question tonight. not answered, held. But let me leave you as the night closes with the thought that first set us walking, now that you can feel its full weight. If the block universe is right, and it may well be, then nothing you have ever lived is gone. Every moment you have passed through is still there, at its place in the fabric of reality, exactly as real as this one, permanent and safe, beyond the reach of any river to carry it away. The afternoons you remember with longing have not fallen into nothing. They are still there, with the light just so, with the people who were in them still in them. You have not left them behind. You have only walked on, carrying the strange and beautiful inability to see any moment but the one your feet are standing in, mistaking your own walking for the vanishing of the world. And this moment too, this quiet moment now, with you lying in the dark at the end of your day, listening to a voice tell you that time may not take everything after all, this moment will not vanish either. It will stay, held in the fabric, one small, permanent place in the vast and gentle landscape of everything that has ever been. Wherever you go from here, whatever tomorrow's slice reveals to you, you will never truly leave this quiet. It is yours, and it is kept. Rest now. Let the question stay open beside you like a candle that does not need to be answered to give its light. There is nothing you must decide tonight, nothing you must lose, nowhere the present is rushing you off to. You are here, and here is real, and here, it may be, is forever. Sleep well. Good night. And let me say one true thing about why this question, of all the questions we could spend a night on, is worth carrying to sleep. It is not because knowing the answer would change what you do tomorrow, because it would not, and it is not because the block, if it is true, offers any escape from loss as we live it, because from the inside we still say goodbye and still feel the ache of moments ending. It is worth carrying because it gently loosens the grip of one particular fear, the fear that time is purely a destroyer, that everything we are and everything we love is being continuously fed into nothingness and annihilated, that the past is a graveyard growing behind us with every breath. The physics does not promise you that this fear is misplaced, but it opens, honestly and with the full authority of our best tested theories, the real possibility that it is, the possibility that nothing is destroyed at all, that the universe keeps everything, that every moment you have lived stands permanently in the fabric of what is, unreachable to you perhaps, but not erased, not gone, not nothing. Whether that possibility is the truth, no one can yet tell you for certain. But it is a possibility that lives inside real physics and not inside wishful thinking, and there is a great and quiet difference between those two, and it is enough, I think, to rest on. So here at the end, let the question be soft. You do not need to know whether the block is real to feel the peace it offers as a possibility. You do not need to resolve the oldest debate in philosophy to close your eyes. All the great thinkers who have given their lives to this, from Parmenides to Einstein to the physicists arguing it still, have laid their heads down at night with the question unanswered, and slept, and woke, and the universe held them through the night whichever way the truth runs. It will hold you too.